In a world where rapid advancements in technology are reshaping our understanding of the universe, NASA is poised to take significant strides in Earth science over the next 50 years. The finale of NASA's Earth series, hosted by Patty Boyd and Jacob Pinter, features insights from prominent scientists Christa Peters-Lidard and Dalia Kirschbaum, who are at the forefront of this exploration. Their discussions highlight both the accomplishments of NASA's Earth science missions and the challenges that lie ahead in our quest to understand our planet. NASA's Earth science program has a rich history dating back to the 1960s, when astronauts first captured the iconic Earthrise photograph during the Apollo missions. This moment not only provided a breathtaking view of our planet but also instilled a sense of interconnectedness, prompting a new branch of science focused on studying Earth as a holistic system. Today, NASA's extensive database of Earth observations spanning over 5 decades allows scientists to analyze changes in the environment and predict future trends. We can see how Earth's surface has changed during that time, Pinter notes, emphasizing the importance of leveraging historical data to inform our understanding of the planet's evolution. As technology continues to advance, NASA is transitioning from older missions like the Earth Observing System towards innovative new projects that will enhance our comprehension of Earth systems. In this context, Peters-Lidard and Kirschbaum discuss the importance of understanding the water cycle, climate change, and air quality, which play critical roles in sustaining life on our planet. We're using data assimilation to understand how our water is changing over the Earth, Kirschbaum explains, illustrating the collaborative efforts made by Earth scientists in analyzing these vital resources. The podcast delves into the unique perspective of Earth as the only known habitable planet, which serves as a benchmark for searching for life elsewhere in the universe. Peters-Lidard underscores this point, stating, "Everything we know about life and how life works on a planet is based on Earth." This connection not only fuels scientific inquiry but also informs our search for exoplanets that may share similar characteristics to our own. The two experts also reflect on the evolving nature of Earth science, particularly in the context of emerging technologies such as artificial intelligence and machine learning. As they face the challenge of reduced flagship missions in Earth science, they see opportunities for more agile, innovative approaches that can yield faster results. We may not have these big flagship missions in Earth science in the same way that we had when we started, Kirschbaum notes, emphasizing the need for adaptability in the field. The conversation shifts to the future of Earth science, where both Peters-Lidard and Kirschbaum express their hopes for the next half-century. They anticipate an era where interdisciplinary collaboration becomes paramount, allowing for a deeper understanding of complex Earth systems. "I want to learn how we can better connect across disciplines and also how we can connect better with our communities," Kirschbaum states, highlighting the importance of inclusivity in scientific communication and application. As the discussion wraps up, the potential for groundbreaking discoveries looms large. Peters-Lidard expresses her curiosity about where and when we will find life in the universe, while Kirschbaum emphasizes the importance of uncovering the unknowns in our data. "There are so many unknown unknowns that we are going to uncover with data that we didn't even imagine was possible," she asserts, hinting at the vast potential for future exploration. As NASA continues to push the boundaries of Earth science, the integration of new technologies, a commitment to responsible research, and a focus on collaboration will be crucial. The next 50 years promise to be an exciting journey, with the potential for transformative insights that could change our understanding of not only Earth but also the universe at large. As we look ahead, the mission remains clear: to deepen our understanding of our home planet, ensuring that we can protect it for generations to come. In a remarkable tribute to the groundbreaking contributions of Katalin Karikó, a Vienna exhibition has recently celebrated her pivotal role in advancing mRNA technology, which has transformed the landscape of modern medicine. Karikó, along with her collaborator Drew Weissman, was awarded the Nobel Prize in Physiology or Medicine in 2023 for their innovative work that led to the development of mRNA vaccines, notably those used in the fight against COVID-19. This exhibition not only honors her scientific legacy but also emphasizes the ongoing impact of her research on public health. Karikó's journey from Hungary to becoming a leading figure in biotechnology is a testament to her relentless pursuit of advancing RNA science. Her research, which initially faced skepticism, laid the foundation for the mRNA vaccines that have proven crucial in combating the global pandemic. The exhibition in Vienna showcases her achievements, highlighting the importance of mRNA technology in vaccine development and its potential applications in various therapeutic areas. The event also coincides with ongoing discussions within the scientific community about the future of mRNA technology. With Karikó's work paving the way, researchers are now exploring the broader applications of mRNA beyond vaccines, including its potential in cancer treatments and other infectious diseases. The exhibition serves as a reminder of the transformative power of scientific innovation and the importance of supporting research that can lead to significant advancements in healthcare. As the world continues to grapple with the implications of emerging diseases, the legacy of Katalin Karikó stands as an inspiring example of how perseverance and creativity in research can lead to life-saving solutions. The ongoing developments in mRNA technology promise an exciting future, with the potential to revolutionize not only vaccines but also a wide array of therapeutic interventions. In parallel to the exhibition, the scientific community is witnessing a surge in initiatives aimed at enhancing mRNA research capabilities. Companies like TriLink Biotechnologies have recently launched advanced mRNA synthesis kits that promise to double mRNA yields while significantly reducing undesired byproducts. By streamlining the synthesis process, these innovations are set to facilitate further research and development in RNA-based therapies. As the field of mRNA technology continues to evolve, the collaboration between academic institutions and industry leaders will be essential to harness the full potential of this revolutionary platform. With the ongoing support for research and development, the future of medicine may be shaped significantly by the innovations that stem from the work of pioneers like Karikó and her contemporaries. Prostate cancer remains a significant health concern, affecting approximately 1 in 8 men during their lifetimes. The recent diagnosis of former U.S. President Joe Biden has once again thrust this prevalent disease into the spotlight, reminding us that while prostate cancer can be serious, many cases are slow-growing and not life-threatening. Dr. Hayley Luxton, head of Research Impact and Engagement at Prostate Cancer UK, categorizes prostate cancers into 2 types: pussycats, which are slow-growing and typically harmless, and tigers, which are aggressive and require urgent treatment. Research indicates that over 50% of men aged 90 and above have prostate cancer cells, often undiagnosed during their lives. Most men eventually will have prostate cancer cells, states Dr. Cody Waddling from the U.S. National Cancer Institute, highlighting the distinction between mere presence and clinical significance, which encompasses symptoms and potential spread. Understanding the risk factors associated with prostate cancer is crucial. According to experts, 3 uncontrollable factors significantly influence risk: age, ethnicity, and family history. The likelihood of developing prostate cancer escalates after age 50, with most diagnoses occurring in men over 70. Furthermore, black men are twice as likely to develop the disease compared to their white counterparts, a disparity that researchers are still striving to understand, potentially pointing to genetic influences. A family history of prostate cancer, especially when diagnosed before age 60, increases risk, as does a history of breast or ovarian cancer linked to BRCA2 gene mutations. While some lifestyle choices are often touted as preventative measures against various cancers, the connection between diet and prostate cancer risk remains unclear. Dr. Waddling notes that extensive research has failed to establish strong evidence for modifiable risk factors. Some studies hint at a possible correlation between high dairy consumption and increased risk due to IGF-1, but the evidence is not definitive. Conversely, emerging data suggests that obesity may correlate with more aggressive forms of prostate cancer. However, this relationship is complicated by the fact that overweight individuals may be less likely to undergo early screening. Prostate Cancer UK emphasizes the need for men over 50 or those over 45 with higher risk factors to engage in discussions with their healthcare providers. Using prostate cancer UK's online risk checker can facilitate this conversation, potentially leading to screening tests such as the prostate-specific antigen PSA blood test and MRIs. In summary, while Joe Biden's diagnosis has led to a surge of interest in prostate cancer awareness, it is essential to clarify that the majority of risk originates from age, family history, and ethnicity rather than lifestyle choices. Maintaining healthy habits is still beneficial for overall health and may help lower the risk of aggressive prostate cancer. For those at higher risk, proactive discussions with healthcare professionals are imperative for early detection and intervention. As research continues to evolve, the focus will likely shift towards understanding the biological mechanisms behind prostate cancer and developing targeted therapies that can improve outcomes for men diagnosed with this disease. The ongoing dialogue in the medical community underscores the importance of awareness and education in combating prostate cancer effectively. In a significant move to address the growing demand for skilled professionals in artificial intelligence, Rice University has announced the launch of a Bachelor of Science in Artificial Intelligence AI program set to commence in the fall of 2025. This new degree is part of a broader strategy by the university to position itself at the forefront of AI education and research, reflecting the increasing importance of AI across various sectors from healthcare to finance. Rice University's President Reginald Desroches emphasized the institution's commitment to leading in areas of national and global importance, stating, "This program exemplifies how Rice is translating its strategic vision into action." The new major is designed to equip students not only with technical skills but also with a comprehensive understanding of the ethical implications and societal impacts of AI technologies. The emphasis on responsible AI aligns with the university's strategic plan, which identifies AI as a catalyst for discovery across multiple disciplines. Amy Dittmar, Rice's provost, noted the urgency of preparing students to shape the future of AI responsibly. "We are in a moment of rapid transformation driven by AI, and Rice is committed to preparing students not just to participate in that future but to shape it," she remarked. This sentiment is echoed by Louis Knockley, Dean of Engineering and Computing, who highlighted the program's aim to develop not only skilled practitioners but also thoughtful leaders in the field. The program, to be housed within the Department of Computer Science, will provide a cohesive curriculum that encompasses a wide range of AI approaches. John Grainer, the program's director, pointed out that the new major will offer a structured pathway for undergraduates, moving away from the current model where students must piece together elective courses or pursue advanced degrees to gain a comprehensive understanding of AI. The curriculum will incorporate interdisciplinary studies, including courses in cognitive psychology and ethics, ensuring that students appreciate the broader context of AI. Vicente Ordóñez Roman, an associate professor involved in the major's development, noted the importance of these additional perspectives, stating, "Artificial intelligence relies on the notion of intelligence. So a course on cognitive psychology will be included in the AI core curriculum." As Rice prepares to roll out this innovative program, it positions itself among a select group of universities in the U.S. offering a dedicated undergraduate AI major. The program aims to leverage the university's strengths in computing and education while fostering a responsible approach to AI development and application. In a parallel development, the University of Texas at San Antonio UTSA is also making strides in the field of AI, with the establishment of its College of AI, Cyber and Computing set to officially launch in fall 2025. Fred Martin has been appointed interim dean as the university prepares to integrate disciplines in AI, cybersecurity, computing, and data science across 4 specialized departments. This initiative aims to enhance collaboration and innovation while addressing workforce demands in emerging technologies. As both Rice University and UTSA embark on these ambitious educational ventures, they reflect a growing recognition of the transformative potential of artificial intelligence. Institutions are not only responding to current labor market needs but are also taking proactive steps to shape the future landscape of AI research and application. Looking ahead, the establishment of specialized programs at leading universities signals a commitment to equipping the next generation with the skills necessary to navigate a rapidly evolving technological landscape. As AI continues to permeate various aspects of life and industry, the educational frameworks being developed now will likely play a crucial role in shaping ethical and effective AI practices in the years to come. In the quest for sustainable and renewable energy, nuclear fusion stands out as a tantalizing possibility, often likened to the very processes that power the stars. As the world grapples with climate change and dwindling fossil fuel reserves, researchers are increasingly optimistic about harnessing fusion energy, a process that combines light atomic nuclei to release vast amounts of energy. Unlike its fission counterpart, which splits heavy atomic nuclei and generates significant radioactive waste, fusion promises a cleaner, virtually limitless energy source with minimal environmental impact. The potential of nuclear fusion is profound. The primary fuels for fusion, deuterium and tritium, are abundant and can be sourced from seawater and lithium respectively. A single gram of fusion fuel can produce energy equivalent to burning 10 tons of coal, underscoring the remarkable energy density of this process. Moreover, operational fusion reactors emit no greenhouse gases, significantly reducing their environmental footprint compared to fossil fuel-based energy sources. Despite its promise, achieving practical nuclear fusion has remained a formidable challenge. The process requires creating and sustaining extreme conditions, temperatures exceeding 150 million degrees Celsius, and effective plasma confinement to achieve a net energy gain. However, recent advancements have pushed us closer to realizing self-sustaining fusion reactions, referred to as ignition. Key breakthroughs include developments in materials science, magnetic confinement technologies, and innovative reactor designs. Among the most notable projects is the International Thermonuclear Experimental Reactor ITER in France, which exemplifies global collaboration in fusion research. ITER aims to demonstrate the feasibility of fusion as a large-scale energy source and is set to begin its first experiments in 2034. This massive tokamak facility will utilize powerful magnetic fields to confine plasma at extremely high temperatures, marking a significant step towards commercial fusion energy. In parallel, various other reactor designs are being explored. Mini tokamaks, like those developed by Tokamak Energy and Commonwealth Fusion Systems, leverage high-temperature superconducting magnets for more compact and efficient reactors. Stellarators, though complex and costly, offer unique advantages in plasma confinement without the need for pulsed operations. Meanwhile, the National Ignition Facility (NIF) has made headlines by achieving record energy outputs, recently surpassing its previous milestones with a fusion yield of 8.6 megajoules, more than doubling its 2022 output. India too is making strides in fusion research, spearheaded by the Institute for Plasma Research (IPR). With a strong foundation in nuclear science, India is already a partner in the ITER project and is developing its own tokamak facilities. The country stands to benefit economically from fusion, potentially adding $6.8 trillion to its economy by tapping into the global fusion market valued at an estimated $40 trillion. Globally, the successful development of commercial fusion reactors could redefine energy geopolitics, reducing reliance on fossil fuels and supporting the transition to a carbon-neutral economy. However, challenges remain, including high initial costs, scalability, and the establishment of regulatory frameworks to ensure safety and accessibility. As we stand on the brink of what could be a revolutionary transformation in energy production, the journey toward harnessing the power of the stars is both inspiring and ambitious. The ongoing research and collaboration in fusion technology exemplify humanity's ingenuity and determination to secure a sustainable energy future. With continued investment in global cooperation, the dream of nuclear fusion may soon transition from theory to reality, reshaping our energy landscape for generations to come. In an era defined by rapid technological advancement, the scientific community is brimming with excitement over groundbreaking developments in quantum mechanics and superconductivity. Recent discussions and research initiatives highlight the profound implications these fields hold for future technologies. Notably, The recent exploration of the emergent topological superconductor candidate 2MWS2 has garnered attention within the academic community, suggesting potential pathways for the next generation of electronics in quantum computing. Published by the American Chemical Society on May 19, 2025, a study delves into the phase stability and structural transitions of 2MWS2, a material that could redefine our approach to superconductivity. Superconductors, materials that conduct electricity without resistance under certain conditions, were first discovered over a century ago, yet their practical applications have only recently begun to flourish. The research surrounding 2MWS2 could pave the way for high-performance superconducting devices, spurring advancements in energy transmission and magnetic levitation technologies. On the heels of this research, the Joint Institute for Nuclear Research (JANR) hosted a seminar featuring Mikhail Shandov, a senior researcher at VLHEP, who presented on superconductors and their ability to defy Ohm's law. In his talk, Shandov emphasized the unusual properties of superconductors, which have fascinated scientists since their discovery. Superconductivity is not just a phenomenon, it's a gateway to understanding complex quantum behaviors, he stated, underscoring the significance of ongoing research in this area, particularly with regard to high-energy particle accelerators. Meanwhile, the University of Zurich marked the centennial of quantum mechanics by declaring 2025 the International Year of Quantum Science and Technology. Physicist Titus Neupert discussed the profound transformations initiated by quantum theory, stating, "Quantum mechanics completely escapes our intuition and sometimes seems almost magical." This year not only commemorates the foundational work of pioneers like Erwin Schrödinger, but also celebrates the onset of what Neupert refers to as the second quantum revolution. This new phase seeks to harness quantum principles for technological applications, including quantum computing and cryptography. Neupert elaborated on the potential of quantum computers to revolutionize processing power. Quantum computing promises exponentially greater computational power compared to that of classical computers, he noted, emphasizing the need for substantial advancements in quantum bit technology to unlock this potential fully. Current quantum computers, while functional, require further scaling to realize their capabilities fully. We need to explore various materials to determine the best fit for quantum bits, Neupert explained, pointing towards ongoing research in superconducting components and ultra-cold atoms. The implications of these advancements extend beyond computing, they hold promise for significant improvements in medicine as well. Neupert speculated on the future of personalized medicine, which could leverage advanced quantum sensors for precise disease detection and treatment. Improved sensor technology could enable the production of customized drugs tailored to individual patient needs, he said, envisioning a healthcare landscape transformed by quantum technology. However, as with any powerful technology, the potential for misuse looms large. Neupert acknowledged the dual-edged nature of these developments, especially concerning military applications. Quantum technology could completely revolutionize military capabilities, particularly in sensor technology, he warned, highlighting the need for responsible stewardship of such potent tools. As researchers continue to unravel the mysteries of quantum mechanics and superconductivity, the future appears ripe with possibility. The ongoing exploration of materials like 2MWS2 and the increasing focus on practical applications of quantum principles signal a transformative era ahead. With each breakthrough, we inch closer to a reality where the extraordinary capabilities of quantum technology become integral to everyday life, reshaping industries from healthcare to computing and beyond. The second quantum revolution is not just on the horizon, it is unfolding before our eyes, promising to redefine the very fabric of our technological landscape.